Hi, physics. This is Mr. Janowski. This is Chapter 9, Homework 5, Problem 4. And this is a lot like the problem that we did in class. We just have a different appliance here. This is a 1500-watt space heater. The other one was an 1100-watt microwave, I believe is what it was. Anyhow, here's what's going on. We have a 1500-watt space heater. So before we even do step what exactly is this 1500 watts? 1500 watts is the power of the space heater. Power comes in watts. So we have that. And then a couple of other useful ideas we're going to have are, what is a watt? A watt, so that's W for watt, not for work, is a joule per second. And if that's true, that also means that a joule is a watt times a second. So these ideas will end up being useful. So part A, how much energy does it use if you forget to turn it off and it runs all night? A time of 8 hours. Okay, so now we do step Step for part A. It's how much energy does it use? I wish I had phrased this question a little bit differently. It would be a little bit clearer to students who are learning this if I had said instead, how much work does it do? Because energy and work, they both come in joules. It's energy and work are basically the same thing. Okay, so we're looking for work, and it will have units of joules. So how can we do this? So for part A, well, we know, where's the formula? This one. We know that power is equal to work over time. We want the work. We know the power. That's 1500 watts. And we know the time. The time is 8 hours. So if power is work over time, that means work is equal to power times time. So that's really equal to 1500 watts times the time is 8 hours. Boop. That's how long this thing is on. So 8 hours. All right. Now let me do something here. Remember that a watt is equal to a joule per second. So I am going to replace this watt here with a joule per second. That will make it a little bit easier to see what we need to do. So if we did this math here, we would have joules per seconds times hours. So energy per time times time, multiplied by time. But the time is not in the right units. So we're going to have to do field goal posts here to get our time in the right units. So we're starting with 8 hours. All right. Ultimately, we want to end up in seconds. So first, let's go from hours to minutes. So we're going to need field goal posts for this. So if we're in hours and we want to get out of hours, that means we need hours on the bottom and minutes on the top. And the top and the bottom need to be the same thing. So how many minutes are in an hour? Okay, they should have taught you this a long time ago. 60 minutes in an hour. So if we did this, hour on top would cancel with hour on the bottoms, hour on the bottom. So now we have joules per second times minute, so we're almost there. We need to get out of minutes and into seconds. So what field goal posts will get us out of minutes on the top and into seconds? Well, if we had minutes on the top, we're going to need minutes on the bottom and seconds on the top. So how do I make the top equal to the bottom? Well, 60 seconds is 1 minute. So minutes would cancel with minutes, and then look at these units we have at the beginning. Joules divided by seconds times seconds. So the seconds on the bottom over here will cancel with these seconds. All right, awesome. So if we do all this, the only unit we have left is joules, and that's what we want. So what you need to do is take 1500 times 8 times 60 times 60 divided by 1 divided by 1. Obviously, you don't have to divide by 1. And you end up with a very big number. You end up with 4, 3, 2, followed by 5 zeros. 1, 2, 3, 4, 5 joules. So this is a rather unwieldy kind of number. So let's turn this into something a little bit easier to deal with. First of all, if you have a big number like this with a bunch of zeros, start from the right, count in 3 places, throw in a comma, count in another 3 places, throw in a comma, and we end up with 43,200,000 joules. So you can leave your answer like that. This is one of the answers. You could also use scientific notation, in which case this would be 43.2 times 10 to the 6th joules. So that works. And the other way to write it is with metric prefixes. So times 10 to the 6 means million. So that's mega. So you could also write this as 43.2 megajoules. So any one of these is correct. It didn't specify joules or megajoules or whatever. So any one of these worked. So the next thing to do, part B. How much does this cost at 11 cents per kilowatt hour? So part B, we want to know something in units of money. $sign question mark. What are we actually looking for here? We're actually looking for the work. But instead of being in units of joules, it's going to be in units of money, which is weird. But honestly, that's the best way to do these problems. So we actually already know what the work is. We know that the work is 43 million, I'll write it the long way, 200,000 joules. So that's true, but we have it in the wrong units because we have it in joules and we want it in units of money. So what are we going to do? Well, let's use this idea. A joule is a watt second. So it may not be clear why we're doing this, but trust me, I've done these problems enough. I know what to do. Replace joule with watt times second. So that's going to make it a little more obvious what we need to do. Ultimately, what we're trying to do here is we're trying to get energy out of units of watt seconds into units of kilowatt hours, and then from there into units of money. It's supposed to be a $sign. You think I could write a $sign by now? So that's what we're trying to do. So we want to get out of watt seconds into kilowatt hours. So first, let's deal with the watts part. I want to get out of watts and into kilowatts. So if you know your metric prefixes, even if you don't, it's written right down here. 1 kilowatt is equal to 1,000 watts. So what is my field goal post going to look like? Well, I have watt on the top over here, which means I want watt on the bottom over here, and kilowatt on the top. And how do these things relate? Well, 1 kilowatt is the same thing as 1,000 watts. So if I were to do this, I would now have kilowatt seconds as my units. So I'm getting closer. But now I have to get out of seconds and into first minutes. So how do I do that? More field goal posts. So seconds on the top means I want seconds on the bottom. Minutes on the top. How do minutes and seconds relate? Well, 1 minute is the same thing as 60 seconds. So seconds cancels here, cancels here. Now I have kilowatt minutes. I'm getting very close. I want to get out of minutes and into hours. So minutes goes on the bottom, hours on the top. How do minutes and hours relate to each other? Okay. An hour, 1 hour, is the same thing as 60 minutes. So now minutes and minutes cancel. So now look at the units that I have left. I have kilowatt hours. So I'm so very close. I just need to get from kilowatt hours into money. And the field goal posts that do that is right here. Typically, I mean, it varies region to region and even, what time of year and what hour of day. But 11 cents per kilowatt hour is a fairly typical rate for electricity. So I want to get out of kilowatt hours on the top, which means I want kilowatt hours on the bottom. And how does that relate to money? Well, according to the electric company, 11 cents is the same thing as 1 kilowatt hour. So watch the units. Kilowatts on the top, kilowatts on the bottom, they go away. Hour on the top, hour on the bottom, that goes away. Which means the only unit I have left is American dollars. So that's good. So now what I have to do is all of this math. I have to take 43 million. Let me start doing it in the calculator. 43,200,000. I have to multiply it by 1. Multiply by 1, multiply by 1, multiply by 0.11. So by 11 cents. And then I have to divide by 1,000, and then divide by 60, and then divide by 60. And again, I would recommend doing it in that order. When you're doing these problems, do all of the multiplication first, and then do all of the division. You don't have to do it that way, but if you do it that way, you're less likely to make silly mistakes in the calculator. So once we do all of this, you will end up with a number 1.0 432. So that is a reasonable amount of money. If you leave your space heater on all night long, it might end up adding $1.32 to your electricity bill. Now, very quickly, let me point out, when people are first learning this and they don't know how to do the field goal posts, they might flip them all upside down. So hypothetically, let's pretend that we had 43,200,000 watt seconds. But then instead of doing it by 1 over 1,000, we did it by 1,000 over 1. So multiply that by 1,000. And then multiply that by, instead of 1 over 60, do 60 over 1. And then do the next one, 60 over 1. And then do the next one, 1 over 11 cents. So really we're dividing by 0.11. So if I do all of that, I would end up with some number like this. 1.4138. So I'll just leave it here. 1.14 times 10 to the 15th dollars. So how many dollars is that? 141. So let's go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then put the commas back in. So this would be a million, billion, trillion, quadrillion dollars. If you get your field goal post wrong, you're going to end up with a number 1.410 quadrillion dollars. I'm not sure that such an amount of money even exists in the world. I'm getting an Austin Powers kind of moment here. That's a ridiculous number. So when you do your step at the end, you want to make sure that your answer makes sense. If you leave your space heater on, might it add $1.32 to your bill? Yeah, that seems reasonable. Might it add $1.4 quadrillion to your bill? No, that doesn't make any sense. If you write down a number like that, an alarm should go off in your head saying that's too much money. So, moving on. Part C. How long could this amount of energy power a 60-watt light bulb? Provide your answer in seconds, minutes, hours, and days. Okay, so for part C, how long? What we really want is time, and we want time in units of seconds, and also in minutes, and also in hours, and also in days. Okay, so what are we really doing here? We're starting with, not 3. Okay, for part C, start with the formula. Start with power as work over time. We're trying to solve for time. We're going to get to time is equal to work over power. All right, we already know the amount of work. The amount of work is 43,200,000 joules. And then on the bottom, what do we have? The power here was 60 watts. And first we want this in units of seconds. Okay, well, let's go back to this idea. A joule is a watt second. So I'm going to replace this J here with a watt second. Sorry, I almost did by seconds. Watt times seconds. Okay, well, watts in the bottom cancels with watts in the top. If I do this number divided by 60, I'm going to end up with an answer in seconds. So 432,000,000 divided by 60, and I end up with 720,000 seconds. So that would be part of my answer. The thing is, I don't know, I don't have a good feel for how much time 720,000 seconds is. So let's turn this into minutes. So what field goal post, this is just field goal post practice basically, will get me out of seconds and into minutes. Well, I have seconds on the top, so I want seconds on the bottom and minutes on the top. 1 minute is 60 seconds. So take that number, multiply it by 1, optional, divide it by 60, and you end up with 120, 00. So now we have 12,000 minutes. Okay. I still don't have a good feel for how long 12,000 minutes is. I'm not used to talking about that many minutes. So I need to get out of minutes and into hours. Okay. So what field goal post get me out of minutes into hours? Well, I had minutes on the top. So I want minutes on the bottom, hours on the top. 1 hour is 60 minutes. Minutes goes away. If I do this, I would have my answer in hours. So divide that number by 60, and you end up with 200 hours. Okay, this is starting to get more reasonable. I have some sense for how long 200 hours is, but I would rather have this amount of time in days. So I need one more set of field goal posts to get me out of hours and into days. So how do hours relate to days? Well, there's 24 hours in a day. I'm starting with hours, which means I need hours on the bottom and days on the top. One day is the same thing as 24 hours. That's an H. It looks like an N. Hours cancel. So if I do 200 times 1 divided by 24, I'm going to end up with 8.33 repeating. I'll just round it off there. Days. Okay. I know what 8.33 days is. That's, 8 days a week. The Beatles. Great. Wonderful. So you have that. And I'll tell you what, I feel like this video is already getting long, so I'm not even going to do part D. It would be the same thing, though. Here, I'll start it. I won't actually do it, though. For part D, what are we looking for? You also want, you want time in seconds, minutes, hours, days. So how would you start this? Again, start with your formula, your basic definition of power. Power is work over time. Well, that means time is work over power. Our work is still 43,200,000 joules, but let's just call it watt seconds. And our power now for part D is we're trying to see how long could that, 8 hours of the space heater, how long could that power a 10-watt LED bulb? So you would divide it by 10 watts. Watts would go away, and you keep going from there. So that's how you do it. So unit conversion is a really, really useful skill in sciences, especially physics and chemistry. To be able to do this, to get out of one unit into another unit, is very, very useful. So it's not that hard once you get a little bit of practice in it. So do that. Get a little bit of practice in it. Hopefully you found this helpful.